Oh, it's okay.
I went too fast.
Uh, yeah, something's going on with the settings. Do you see my screen?
Yeah, I can see it.
Oh yeah.
Yeah,
I
yeah.
see. You see, I wrote hi.
Yeah, two dots and a high.
Okay. All right. Okay. So, you let's do linear equations again just to reinforce it.
Yeah.
So if you have 5x plus 3 equals 7x plus 2, how do you solve for x?
Wait, I think we did it somewhere, right?
Oh, we did something very similar, yeah, in the other
No, I
one.
don't think it's similar. I think it's actually the same thing.
Oh, really?
Yeah, let me just check my book.
Yeah,
Let's
I
see
do have
pages.
I have some of them over here.
Yeah,
Oh, that was the other one. But
hmm. What as always could be the last paper I'm searching.
what's that?
I was just talking to myself.
Okay.
Because it's always in the left page where the thing I'm searching. So,
Yeah.
hmm. Oh, oh, oh no, it's actually not the same. It's just similar. You actually did last time we did 5x plus 4 equals 7x minus 2.
Okay. Yeah. Looks similar, but
Yeah.
not. Yeah. So you can look through how we did it last time, or what we were kind of like our smaller objectives to solve the greater objective. Um,
Yeah.
and so what's our goal here? What are we trying to do?
Wow. Why's my chat like this? I don't want this shit. Alright, maybe like this. What? Oh, yeah, finally. Okay.
So so we're trying to get all the x's on one side and all the non-x's on the other side, the numbers, right? So just the numbers. So get all the x's to one side and get the constants to the other side of the equation, right?
Right.
So so we might start canceling out x's on one side so that we can get them to the other side, right? So if we want to get rid of this 5x on the left side, what would we subtract from both sides?
Um, besides, wait, you.
So we might subtract 5x from both sides, right?
Right.
So minus 5x on this side and a minus 5x on this side.
Okay.
So when we do minus 5x on the left side, it cancels,
Right.
right? That 5x minus 5x is 0.
Mm-hmm.
I said we get 3. We just copy it down left to right, right? 3 equals 7x minus 5x, which is what?
2x.
2x. Yeah, 2x plus 2.
Right.
And so now we have all the x's on the right side. So we want to get the constants on the left side. So what do we do now?
Hmm.
So we want to get rid of this plus 2, right? So what's the opposite of
Yeah.
adding 2? Subtracting 2, right?
Right.
So we subtract 2 from both sides. And now this cancels on the right-hand side. So we're just left with 2x on the right-hand side.
Right.
What does the left-hand side become? It's 3 minus 2, right?
Right.
So what's 3 minus 2?
3 minus 2. 1.
Yeah, it's 1. So, and we want to get a coefficient of 1. This has a coefficient of 2,
Yeah.
right? So if we want a coefficient of 1, we just see this is being this x is being multiplied by 2. So what's the opposite of multiplying by 2?
Uh, hmm.
The opposite of multiplying by 2 is dividing by 2.
Oh, right.
So we divide both sides by 2, and then this cancels to give us a coefficient of 1x, which we could just say x, right? Solving for x. And x is then equal to 1/2.
Right.
You have any questions about that?
No.
Okay. So that's where there's one solution. Last time we showed that if it was like something equals something different, then this is no solution.
Yeah.
So this would be no solution. This is one solution. And if it was like 5 equals 5, then that would be all real numbers.
Yeah.
So do you want to do another one similar to what we just did?
Why not? Let me just rethink. Yeah.
Yeah, you want to do that? Okay, so let's go with 5 or 5x minus 2 equals 2x minus 2.
Yeah. Hmm. So you just because it's the same thing. I don't think it's possible at all.
Well, you can always get an answer. The answer may be no solution, but you can always get an answer.
I think it's no solution.
Okay, so let's say we add 2 to both sides. Your intuition is pretty good, but I think it happens to be wrong in this case. So if we add 2 to both sides, then these 2's cancel and these 2's cancel, right?
Yeah.
And we get 5x equals 2x.
That makes no sense.
So if it was 5 equals 2, it would be no solution, right?
Yeah.
But there is one answer here if it's 5x equals 2x, and that is if x equals what?
X equals 1.
If x equals 1, then that's not a solution because that's 5 equals 2, right?
Right.
5 can't be equal to 2, but what x makes 5x equal to 2x?
Hmm.
So
I
we could subtract 2x from both sides, right?
yeah.
And then what is the right hand side going to be? So
I
the right hand side becomes 2x minus 2x, right?
right.
What's 2x minus 2x?
2x minus 2x isn't like 0x?
Yeah, it's zero. It's just zero. Yeah, zero x, which is zero because anything times zero is zero, right? And then 5x minus 2x becomes how many x?
Can you repeat that, please?
5x minus 2x
Yeah.
becomes how many x?
Uh, 2x minus 2x equals 0x.
5x minus, yeah, this is 0x on the right,
Yeah.
but on the left hand, so what does the left hand side become?
Hmm.
It's 5x minus 2x, right?
Right.
Which is how many x?
I don't.
Because this is x times 5 minus 2,
Yeah.
so it's 3x.
Oh, yeah.
So 3x equals 0. So if we wanted to get x by itself, what would we do to get rid of that 3?
Well, put the x one.
So if so we is being multiplied by 3, so we just divide by 3, right?
Right.
And then it becomes x equals 0 over 3, which is simplifies to what?
X minus what?
X equals 0.
Yeah, but it was make zero then.
Yeah, so if x equals 0, then 5. So if we just took this part, right? 5x equals 2x.
Yeah.
5x equals 2x. Then that would be 5 times 0 equals 2 times 0.
Yeah.
So that's just 0 equals 0. But that's not, so 0 equals 0 won't, this is not all real numbers. This is just, the answer is 0. So x equals 0 is the solution.
So it does make sense.
Yeah, yeah, it does. But I see where you were going with that because it looked like 5 equals 2, but 5 equals 2 is not the same as 5x equals 2x,
Yeah.
right? But that was a good idea because it kind of looked like that.
Okay.
So it's just 0. Yeah.
So the x equals zero.
X equals 0 is the solution.
Okay. So what was wrong?
The one solution. Yeah. Um, so let's go over something here that I want to show you. Question 7. So read question 7 and think about that.
Okay. X. Wait. Oh, question 7. All right.
Just when you're ready, let me know what you think of it.
Yeah. Hmm. I can't find the answer
Okay,
because look, it
so
said. Oh wait, sorry.
oh,
The
good.
new. It said there's a new city hall, a new school, and a new movie theater. But it should not be in the same region. So it does 2 times 4, 8. Then one for the new city hall. Oh, it can. Yeah. Oh, there could be multiple city halls, right?
No, there's only one new city hall, one new school, and one new movie theater.
Yeah. So it cannot be A because yeah. I know it's not A, but I can't find it between B, C, D, E.
Okay, so like there's different ways of doing this, but the easiest way is to actually draw out a tree of kind of like combinations, right?
Right.
So if we said that each stage of the tree was the building,
Yeah.
right? So if um we said the first stage, well let's say that the first stage is so the school and the movie theater can't be built in the same region. So let's just start with City Hall to simplify things, right?
Right.
So City Hall can be in one of four regions, right?
Right.
So we say one, two, three, four.
Yeah.
And those regions are the four regions, right? So we just say one, two, three, four. And then just without loss of generality, because we have to go through each of these buildings. So if we just arbitrarily define the order in which they're built, then it doesn't matter because they have to be built in some order anyway, right? So
Yeah.
that's without loss of generality. And then we do the new school, right? So now we do school, right? And how many different areas can the school be put in?
It could be like 4 schools.
Yeah, well, four areas, right? Because there's nothing because the city hall and the school can be in the same area, so the school still has four options of going into, right?
Right.
See what I'm doing here? So uh so how many leaves do I have here? How many of these endpoints do I have here?
How many? So you can actually get. Let me think. You can get like 16 schools.
Yeah, exactly. And that's equal to see because there's four here and four here. So it's actually just four times four, right?
Right.
Right. So and then for the third, so the general equation is that it's the number of branches at each stage. So stage one is four branches. Stage two for the school has four branches at each of these branches, so it's four times four. And then stage three is the movie theater, right?
Right.
So if we go here for the movie theater, how many different regions can the movie theater be put in?
Hmm. 16 again.
So it was either going to be because the other two were four, so it was four and four, right?
Right.
But the movie theater It says the school and the movie theater must not be built in the same region.
Oh,
So
you're right.
whereas, yeah, so wherever the school was built, the movie theater cannot be built there. So
So
how many regions does the movie theater have?
so it should be B, right?
Uh, let me see. No, because the movie theater has three other options, right? Because the movie like there are four regions, right? So whichever region the school is built in, the movie theater can't be built there, but the movie theater can be built in three other regions. So this is actually three, right?
Right.
Just dot dot dot, right? So three. So this is three, right? So this is four, four, and three, right? So it should be four times four times three.
Yeah.
You see how I branched out in three stages?
Yeah.
And then what is four times three? So I could be putting these branches here.
Let me think. 16, 48.
Yeah, 48. So that's equal to 48. So you see all these little kind of little branches?
Yeah.
That's the three of them because there's three regions left, right?
Right.
So that's 48 leaves.
Yeah, 48 leave.
So do you see that? If we break it up each stage into the building and
Yeah.
then say the options are the regions, that's easier than saying which regions they are and then breaking it up into the regions for the branches, right?
Oh,
Because
oh.
there's like limitations on the regions or for the buildings, but then we could just reduce the number of regions available.
Yeah.
Okay. Does that make sense?
Yeah.
Cool. All right.
So yeah.
Oh, go ahead.
Yeah, all good, all good.
Okay. All right. And then we did this one. I don't know if you want to do this again, but we already did this one, I think.
Yeah, it's 125 because if you add it all together, it is 250. And since they are repeated twice, we must divide it by two, which 250 divided by two is 125. I remember
Oh
now.
yeah, exactly. Very good. And then we did this one already. I don't know if you want to go over it again.
Yeah.
You want to do this again?
Hmm. No, I'm fine.
Okay. And then we already did this one. I don't know if you want to do this again.
Yeah. No, no, thank you.
Okay. And then there's this one.
Yeah.
Um, so I can give you a similar problem that would help you with this problem,
Yeah.
or some similar problems that would help you with this problem if you want. So let's say that I have some triangle,
Yeah.
and forgive its tail there. And then let's say that I have this other, there's a right angle here. Let's say a right angle here.
Yeah.
Okay, and if I knew that this was 8 and this was say 9, and if I knew that this was 12,
Yeah.
um, uh, find x.
Okay.
So do you okay, so just think about it for a little bit and let me know what you think.
Okay.
And you can do this without any trig functions, without any trigonometric functions.
Well, it is kind of hard to solve.
Yeah, okay. And we can go over it if, or I can show you how to do it.
Okay.
So you see how this little triangle actually they share this angle right here, right?
Right.
So whatever this angle is, it's the same for the little triangle as for the big triangle, right?
Right.
And then they also both have right angles right here,
Mm-hmm.
right? So therefore this angle must also be the same as each other as corresponding to each other, right?
Right.
So whatever this angle is, it's the same as this angle. So
Yeah.
that means that what we have is similar triangles.
Yeah.
So the small triangle is similar to the large triangle. So that means that we can write ratios. We can write a ratio equation, right?
Yeah.
So we might say that the corresponding side ratios are equal to each other. So um, we might say that x, so the bottom x is to 12 as the bottom of the little one is to the, its altitude, this vertical line, right? So the bottom is 8 and the vertical line is 9, right?
Right.
And then we can just to get x by itself, to solve for x, it's being divided by 12. So we want to do the opposite, which is what? Multiplying by 12, right?
Yeah.
X is being divided by 12, so we want to multiply by 12. So
So
the these
so
cancel.
so cancel the divided by 12, I guess.
Yeah, yeah, it's well, we want to multiply by 12 because it's being divided by 12. So because we want to get x by itself with a coefficient of 1.
Yeah.
So 1x equals 8 times 12 over 9, which simplifies to 8 times, if we divide this by 3 and divide this also by 3,
Yeah.
then it's going to be 4 divided by 3. So, right, because 9 divided by 3 is 3, and
Mm-hmm.
12 divided by 3 is 4.
Yeah.
So it's going to be 32 over 3. So x equals 32 over 3.
Yeah.
Okay, so do you have any questions about that?
Nope.
So you can see from in this problem, we actually, because they said that the bottom half below this PQ has the
Yeah.
same area as above PQ, right? But
Right.
what we see here is that um this triangle, this little triangle here,
Yeah.
has this same angle, right? Because these are opposite angles are congruent. So
Yeah.
you see these angles are the same right here. And here's a 90-degree angle right here. So you can
Mm-hmm.
see that this angle is going to be the same. So this little triangle is similar to this big triangle.
Yeah.
This big triangle on the left. So they're similar. So you can write a ratio equation um, for these guys in terms of a variable x or x or y or whatever you might define, which is different from this x and this y. So don't confuse that. But you can name the variable whatever you want. But basically, we can write an equation that says that these four, because this is a unit square, so this is 4. The area is 4 right here, right? And then we
Yeah.
subtract the little triangle and add the big triangle, and then say that that's equal to these 1, 2, 3, 4, 5 right here, or 6 right here, right? Minus the big triangle, plus the little triangle, or sorry, plus the little triangle. So 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 that's how you would get started with that. And I can let you play with it for homework if you want.
Okay.
But do you kind of see what I'm getting at? Do you see how this is 4 right here?
Yeah.
But then they only want you to take above this, so you subtract this little triangle area and add the big triangle area. So, but it's going to be algebraic, right? So you have to do it in terms of x and then solve for x. So that's going to be one of the hard parts of the problem as well. But what's the area of a triangle?
Huh?
What's the equation for the area of a triangle?
I don't get it.
If you have So what's the general equation if you have like say for example, what is the area of this triangle right here that we solved for? What is the area of this triangle, this large triangle? So in general, the area of a triangle is equal to 1/2 the base times the height.
Yeah.
So in this case, it's going to be 1/2 times the base, which is um, x, which is 32 over 3,
Yeah.
times the height, which is what?
The height is 2.
The height is 12.
12. Yeah, 12.
12.
Oh, sorry, I can't. Oh, yeah, sorry, I forgot.
That's okay. So we can simplify this by doing 12 divided by 3 is 4, and 4 divided by 2 is 2. This is going to be what, 64? So you see that I just do 12 divided by 3 is 4,
Yeah.
and then 4 and then I do 4 divided by 2
So it does 2.
is 2, so it's 2 times 32.
So that's 64.
Yeah, 64. Exactly. You see how I simplified it by instead of multiplying out 12 times 32, it's easier to just cancel out 12 divided by 3 divided by 2, or 12
Yeah.
divided by 6, right? So it's faster. Cool. So this is the equation for the area of a triangle. 1/2 the base times the height. So if you look at this, so this is going to be 1 right here for, so if you look at this large triangle,
Yeah.
this is going to be 1. So the height's going to be 1. And then the base is going to be you might have to split it up into these 2 little triangles right here or something like that. So, but it's going to be 1, 2, 3 plus this little guy, or you could just call this whole thing X if you want. But you have to play around with it,
Yeah.
right? And then this guy. So if you call this X right here, this the 1, 2, 3, and then this guy. This is, so if you call this whole thing X, then this guy right here is going to be 1, 2, 3, 4, 5. 5 minus X, right? For the little triangle, for this smaller triangle. 5 minus X. So does that make a little bit more sense?
Yeah, it does.
Okay, cool. Okay, so try that for homework. And then we can talk about it next time if you don't make as much progress as you'd like, or if you just want to go over it.
Yeah.
Okay. And then we already did this one. And then we could try question 13 if you want.
Okay.
So go ahead and read that and let me know what you think when you're ready. This one's
Yeah.
kind of abstract, I guess.
I can't get it.
Okay. Yeah, that's fine. This one is pretty challenging and it took me a really long time to try to figure out. So let's write this equation right here in terms of something that looks more like or closer to this so that we can see. So x over a plus 1 over b is greater than 0, for which the solution is x is less than 1/3. So x over a plus 1 over b is greater than 0.
Yeah.
So x over a plus 1 over b is greater than 0.
Yeah.
Uh, so let's multiply. Let's get all this in one line instead of fractions. So let's multiply both sides of the equation times AB so that we can get rid of the denominators. So we're going to multiply AB times this, and then multiply this times AB also, because we got to do it to both sides.
Yeah.
And then therefore the right-hand side is going to simplify to what?
Simplified to 0.
Yeah, it simplifies to 0, because anything times 0 is 0. And then the left-hand side, we're going to distribute the AB.
Yeah.
And so we get ABX over A
Mm-hmm.
plus, we just put AB over B, right? Oops, I was supposed to put that there. All right, and then this A cancels, right? And this B
Yeah.
cancels. So it's BX plus A is greater than 0, for which the solution is going to be X is less than 1/3.
Yeah.
So we don't know what A and B are, but we can get bounds on A and B by knowing that X is less than 1/3, right? So if we solve, let's solve for um, let's solve for X in the inequality.
Yeah.
Okay, so if we subtract A from both sides, then we get BX is greater than negative A.
Mm-hmm.
And then if we divide both sides by B,
Yeah.
and let's just make sure that okay, so we don't know if A and B are positive. So this is kind of iffy, because if you do an inequality and you divide by a negative number, then it switches them, right?
Right.
You have to switch the direction of the inequality. So, but let's just continue with this just to show you kind of one possible solution. So x is greater than negative A over B, right?
Yeah.
So, but they said x is less than 1/3. So what does negative A over B have to be less than? So
Mm.
I can put this right here,
Yeah.
right? Because x has to be less than 1/3. So I can say x is less than 1/3, right?
Right.
And therefore, based on transitivity, negative A over B, since negative A over B is less than x, and x is less than 1/3, then negative A over B has to be less than.
Less than. Should be less than 1/3.
Yeah, less than 1/3. Exactly. So negative A over B has to be less than 1/3. So, and then if I were to multiply both sides of this equation by -1, then I have to flip the inequality, right?
Right.
So that makes it A over B must be greater than -1/3, right?
Yeah.
So if you look at this, it says determine the solution set of bx minus a is greater than 0. All right, let's go with blue. So bx minus a is greater than 0. So let's solve for a over b or negative a over b or something similar to what we have up there so that we can compare them, right? So this is if
Yeah.
we add a to both sides, we get bx is greater than what? 0 plus a, right?
Yeah.
Which is a. And then if we divide both sides by b, we get this to cancel.
Right.
So we get x is greater than a over b.
B.
So we get that x is greater than, or a over b is less than x. um, but we also know that a over b has to be greater than negative 1/3, right?
Yeah.
So that means that we can put the green part there. A over b is greater than negative 1/3. So therefore, x has to be greater than what?
X has to be greater than a to b.
It's greater than a over b, but a over b is greater than negative 1/3. So x is greater than
1/3.
negative 1/3. So the solution set to bx minus a is greater than 0 is it's greater than negative 1/3.
Yeah.
So does that all make sense?
Yeah.
Yeah. It's kind of weird because it's kind of proofy, but it kind of works. So,
Yeah.
let's see. Okay, did you want to do number? Do you want to look at number 14 for a little bit?
Yeah.
Actually,
Why
let's look
not?
at number 15 because it's related to what we did today. Um, right. So today earlier, we did the whole thing about we multiply the number of branches by each
Yeah.
other at each stage.
Mm-hmm.
So in this case, we're going to find the different paths, where the different shortest paths, and then multiply them by the number of branches at each stage, right?
Yeah. Right.
And so that's how they get the answer that they get because like once you get here, you could go down here or you could go over here, right?
Right.
Like you go up, you can go east and then south, or you can do south and then east, right? So that's kind of like it's kind of like a stage of two right there, right?
Right.
And then once you get here, you kind of have to go here because this is the shortest path, right? Because if you
Yeah.
go this way, and this is due to the triangle inequality, right? Because um, so these are all right angles. So you would always use the Pythagorean theorem. But for the triangle inequality, we know that a third side has to be less than the sum of the other two sides. So this third side has to be shorter than if we add up these two sides, right? So if we go this way, that's going to be a longer way than if we cut through the diagonal.
Yeah.
So we have to go. So if it includes if it doesn't include the diagonal, then that's not the shortest path. That's not a shortest path, right? So we have to get here, and then so to get from here to here, how many different ways are there to get from A to the center?
I don't know.
So we can go down, we can go south and then east, right?
Yeah.
Or we can go east and then south, or we can do. But what's another way? We can go through the middle right here, right? So we can go south, east, south.
Yeah.
And then those are the only three paths that we can take to get to here, which is necessary for a shortest path. So there's three different ways to get from the upper left to the center, right? So there's three ways,
Mm,
and then we always go through this diagonal, and then there's two different ways, right?
right.
So how many ways total is that?
So like 8,
So it's going to be three over here, right?
right?
Times one right here,
Yeah.
times two right here.
Yeah.
So three times two,
So it's 6.
yeah, it's six. Do you see how we get three ways right here to get from A to the center?
Yeah.
Right? Because we can go down, we can go on the outside or we can go on the inside, but that's three different ways.
So
Right. And then
we get to 4 for the short path.
it's three times two.
3 times 2 is, oh yes. Yeah, never mind.
Yeah, yeah. Because if we went any other way without taking this diagonal, it would not have been a shortest path.
Yeah.
Right. So you have to take this one diagonal in order for it to be a shortest path
Yeah.
because of triangle inequality.
Yeah.
Um, okay. So does that kind of make sense?
Yeah.
Okay. Cool. So I think you'll get a kick out of this one. Just look for repeating patterns for
Yeah.
question 14.
Okay.
Uh, and just map out the digits, but it's a lot easier than it looks at first. So you can try that, and yeah, you can do it on paper for sure, and you don't. It doesn't take. I mean, it might take 30 minutes to actually do the calculation, but you just have to find a repeating pattern. So I think you'll get a kick out of this one, number 14.
Okay.
Okay. Do you have any other questions or concerns? Oh, another thing. Look up the triangle medians theorem. Medians of a triangle.
Yeah.
It says this that for any triangle, the three medians, okay, the medians are always from the vertex to the midpoint of the opposite side.
Yeah.
So that see, this is the midpoint because each side has equal lengths on the on uh kind of like to the right and to the left, right?
Yeah.
This is a midpoint because this is equidistant from these 2 points. So the medians will always intersect at the centroid.
Mm.
So that's the median of a triangle theorem. This is true for any triangle. So this is supposed to help with it was a problem that this is supposed to help with, but I can't find the this is supposed to help with question 6.
Yeah.
Yeah. So so try applying that to question 6. Um and let me know if you have questions about that.
No.
Okay. All right. I guess that's all for today, unless you have any other questions or concerns.
No, I'm fine.
All right. I guess I'll see you next week.
Yeah, see you next week.
All right. I'll talk to you later.
Bye.
All right. Bye.